Hi, I'm Jayesh from second year section B BTech Mechanical. So I'm going to discuss the prototype of a slider crank mechanism. Basically, what we need to design a mechanism is the input and its corresponding output. In a slider crank mechanism, the rotary motion is converted to the reciprocating motion. So when we give an input to the crank, the slider reciprocates as an output with the aid of a connecting rod. Therefore, we are interested in designing a mechanism in which the rotation of a crank by a certain angle gives the required displacement of the slider. In my case, I have taken it as for 30-degree rotation of a crank from the initial position, the slider reciprocates by 120 mm, and for 60-degree rotation of the crank from in its initial position, the slider displaces by 288 mm. Also, the eccentricity required is 60 mm. Now, for the development of such mechanism, I have used inversion method. This method is already discussed in my previous video, and the link for the same is at the top right corner of your screen. So let us move to the conclusion of the method applied. I've scaled the drawing as 1:3 for my ease. So we can see that for 30-degree rotation of the crank, we have the displacement of 40 mm, which is 1/3 of the displacement required in our prototype. And for a 60-degree rotation of the crank, the displacement of the slider is 96 mm, which is again 1/3 of the displacement required in our prototype. So what we get from the drawings are the lengths of the crank and the connecting rod. Therefore, by measurement, we found that the length of the crank is 91 mm and the length of the connecting rod is 100 mm. Therefore, in our prototype, this will be 3 times of their measurement. That is, the crank is of 273 mm and the connecting rod will be of 300 mm. Thus, we have obtained our required mechanism. Now, we can see that this is the initial position of the slider and crank. Now we give 30-degree rotation to the crank. So our slider moves from C1 position to C2 position, that is, it is displaced by 120 mm, and we give 30-degree further rotation, that is 60-degree rotation from the initial position. The slider moves to the C2 position, that is, it is displaced by 288 mm. So I would like to discuss one more case where there would be a complete 360-degree rotation of the crank. For this, we will require a shorter crank. So this is our new slider crank mechanism in which the crank is of shorter length. So it is capable of making 360-degree complete rotation. And for the rotation of the crank, the slider reciprocates, and the length by which it rotates is called the stroke length of the slider crank. So I have discussed both the cases where the crank is capable of making complete 360-degree rotation and incomplete rotations. So thank you very much for watching my video.